pleasure to be here. So I've been listening very carefully to all the different sessions, and it's been very interesting so far. So I just want to give a very brief overview of what we're going to cover in this session. So we will talk about 5G standards. But I just want to assess at the moment where we are. What is 5G? All of you have been talking about 5G. 5G, we have quite a lot of different features and services that we can support. So we traditionally, I would say, we have one path for the telco. It's always been one main focus. But now we see this, let's say, fan that is spanning different type of services that they are useful for different applications, which hence means a much more complex type of architectures. But right now, we are actually at the phase that we are starting the standardization of what we call it the 5G advanced. This is, we can see it like the second half of the generation. Normally, a lifetime of any generation is about 10 years. We are the second half, where the first half is creating the first sets of features to focus on what 5G is, like we had for LTE, and then LTE Advanced. And the second one, I would say, is more the fine-tuning, the refining, providing that edge capability. And I don't mean edge in the sense of, edge computing, but it is going a little bit further to make sure that we have the right set of services for the future. And 5G Advanced has promising quite a lot of different extension, particularly in supporting the UAV type of applications. So if we go then to the next slide, I just want to give a very brief overview of what we're going to cover in this session. So what is the main topic of the sessions? It's very simple. So I would say is what is that we're going to do? What is that 5G offer? Just maybe giving a check on where we are. So if we can go to the next slide, so for the audience it's easier. So we can see what is 5G, what is we accomplished so far, what is the next expectation on 5G Advanced, what is covering, why standards are important. And most of us, we are very accustomed to the 2GPP. It's in the telco, is our primary specifications about it. But we also have to take into account whether there is a variety or other activity. And so then we will go through also to touch upon what is that the standards need to go for the next level, and what is that is also the autonomous system brings on how we see the perspective of a general concept of autonomous system in the standards. For this reason, I actually would like to welcome our panelists. So we have some wonderful speakers, but I'm very happy to have you on board. So I'm just going to introduce quickly, and then you can do your own introduction. I'm just going to give you a name. So we're going to have Adrian Buckley from MITRE. Thank you for joining. Then we're going to have Sebastian Thalanany from US Cellular and Wanshi Chen from Qualcomm. So maybe we can go in order, like I mentioned. If you can introduce briefly yourself, what is your expertise, why you're here, what is your view on the 5G standards?
Okay, Barbara, I'll go first. Adrian Buckley, as Barbara said, I'm over at MITRE. I'm looking after their standards. I've been actually doing standards since the beginning of my career, which nearly goes back 29 years. I've done everything from ETSI to 3GPP, IEEE, OMA. I mean, I can keep on listing them, and in some of those organizations, I've been the editor and rapporteur of particular features that have been developed, and I've also in my past launched two GSM networks. One was in the UK, and the other one's been here in California. So I really appreciate being invited to participate in this panel, and I'll hand over to the next person.
Yes, Sebastian, over to you.
Good. Thanks, Barbara. Nice to see you, Adrian and Wanshi. You're all looking very good. I'm actually actively engaged in the evolution of 5G systems towards 6G at US Cellular from an end-to-end perspective. And my background goes beyond 3GPP, PP2. I was with Motorola before that, designed the first digital phone for Japan. And before that, I was associated with the Defense Department building missile flight control systems. So it spans quite an interdisciplinary arena of evolution as systems continue to evolve. So it's a continuing journey. Thank you.
Thanks, Sebastian. Over to you, Wanshi.
Yeah, thank you. First off, really pleasure to be here to join the panel. I'm sure it's going to be a very good discussion. Yeah, my name is Wanshi Chen. I'm currently 3PP round plenary chair. Before that, I was also chairing in round 1 for 4 years. And yet before that, I was round 1 vice chair. So I've been participating in 3PP standardization work for a long time, maybe too long, but anyway, so. And my background also has been, I think, more than 20 years experience in communications. Right now working for Qualcomm. Before that, also worked for Ericsson a few years, and China Mobile also a little bit. So very happy to be here, and hope to do a good discussion with you guys. Thank you.
And I'd also like to add that Wanshi is a marathon runner as well.
Thank you.
Good to know that you find the time.
None of that for me. None of that for me, Sebastian.
To be fair, it's nice to see. So I also have quite a background in standards. So probably we reached a century of standards amongst us, but which is a bit scary. But let's kick off maybe on a little bit, and let's start with you, Sebastian. So, what is that you say the 5G standard is important? What are the values that a standard in general brings? Why we do a standards?
Right. So let me start with the second part of that question first, and why is standardization in general important? And the key term there is interoperability. As I was listening to a little bit about the previous session talking about regulations, we have 3 major regions across the globe with different regulations, different demands, different demographics, different requirements. But yet we need systems to work seamlessly around the globe, which then means that the only alternative is that we need to make them interoperable, and hence we need standards. And that is built on consensus, which is another very important aspect of standardization, because there are so many ways to design a system that we have to find the minimal set of building blocks that would enable interoperability. And then there's, of course, room for innovation and so forth that does not impact interoperability, but essentially improves performance and user experience and so forth. So then coming back to the first part of the question, why do we need 5G standards? So if you go back in time a little bit and go back to maybe 3G, when we transitioned from a circuit switch environment to a packet switch environment, which is a huge paradigm shift. And then, I have this sort of repeating pattern where I can see that every even G is a maturation of the previous odd G. So once we transitioned in 3G, we actually matured in 4G. But then there was this challenge of continuing service evolution. How do we actually improve the service paradigm? And that's what 5G started out with, and then built on top of virtualization, which adds further flexibility, which has other benefits, although it causes more challenges, such as decoupling hardware and software, right? So we don't need tightly coupled hardware software building blocks, which adds to cost, complexity, more challenges. Whereas if we decouple, then we can operate on commercial off-the-shelf hardware with high availability platforms and reliability and so forth, which can be used in a generic way, while the actual functionality can be architected to suit a given objective. So that is from a system standpoint. And then on top of that, in terms of performance, almost every metric is 10x larger. peak data rates go up to 20 gig latencies of the order of 1 millisecond. Flexible numerology to be able to allocate resources more efficiently, a leaner radio interface. So there are so many benefits, and then there are many more beyond that. And then also the decoupling of the control plane and the user plane, which started out in 4G, but then it's been augmented through virtualization and network slicing, which continues to evolve. Thanks.
Thanks, Sebastian, for these introductions. We've seen the good parts, let's say, of the standards, and then maybe I can go to Adrian and says, what are the bad parts? Can you maybe talk about it a little bit on the standard process? And are they introducing problems or not?
Barbara. Yeah, I mean, Sebastian's told us a lot of the great things about standards, but there's always some problems that turn up, and I'd say at this point in time, the success of 5G is also come at some of its downfall. It is. I mean, if you go and have a look at kind of, the earlier wireless systems, we were kind of like catering for a limited market back then. It's kind of like more the traditional consumer it was, and there was limited number of players, involved in those standards. But these problems that I'm going to allude to, actually, they did exist then, but they probably don't exist to the extent that they do now. But it's just the standards. We've gone through the G's, as Sebastian has put it. We've started to expand the scope. People have started to realise, that the cellular industry, can be used for a lot more, types of things. You have, IoT, Internet of Things, who kind of like, jumped on board. You've got the satellite community. The vehicle community, which you hear V2X, which is vehicle to everything, and as we've moved into 5G, you've got a lot more of these players that have come along, and these players, that or industries, they're bringing their own set of, they're all got the particular needs they have. And so now, as well as the traditional consumer and, and operators, that are looking at optimizing their networks, and how they can improve operational aspects, you have like satellite players, you have like the drone ecosystem that we've heard a lot about, already today and yesterday. And everybody's got their particular niche requirements they have. Some of them overlap, but some of them are kind of like niche to that industry. And the thing is, and this isn't just particular to the standards industry. It's probably, you hear it in, a lot of other industries, and in projects in general. You have to achieve something by a particular time frame. You have milestones, and you only have so much time to get that particular milestone achieved in. And so now, with this great big extensive breadth of people wanting things, is that we don't have the time frame, and the bandwidth basically to do it. So now you're encouraging these new verticals to participate, and and also the legacy players. But we can't get everything that they want in that particular release. And what I mean by release, if you look at 3GPP standards process, they have these kind of 18 to 20 month time frames where they say we're going to do this set of functionality, and this is the time frame we're going to get it done in. But each player, they can't get everything in that particular release. So now you have to split the functionality that they might need to get that system to market over multiple releases you have. So now these people are really enthusiastic about, this particular technology. They have to wait a little longer. They do to get it, and then that sometimes, brings, it's problems, they might not get what they need. They may find some alternative to fill in the gaps, and then they may come back to that particular technology, a later instance. There's a technology I worked on, which is IMS, the IP multimedia system. It has its origins back in the late 90s in a forum called 3GIP, and then it came into release 5. Just to give some context, where one of the groups in 3GPP is now on release 19. It is. So it came in at release 5 into 3GPP. It was specified, and then over time there was functionality added to it, more functionality added to it, particular, I think it's the fixed line industry first, then picked up on the IMS to use it, and then eventually it came into the wireless industry in around about 2011. And the thing is, what is IMS? I've been talking about IMS. I mean, IMS is basically a framework that the operator of the IMS system can use to provide kind of like, multimedia services. And today, if you probably look at what IMS provides, and most consumers don't have any visibility of this, is that VoLTE icon that you probably see on the top of your phone. But I mean, this all started back in 1999, it did. And then you eventually have this system that kind of like blew up into this huge amount of functionality. And then with that comes the problem of, well, which pieces do you take? An operator A might want this piece, operator B might want this particular piece, which kind of then starts to fragment the industry. It does. So these are some of kind of like the problems that you can find, and then you've got the other ones where which some of us are probably aware of. I mean, you can have standards, but you also can have competing standards. If you go back to where so the early days of wireless, I mean, you have GSM, you have TDMA, you have the CDMA. I mean, eventually, they all came together. But I mean, you have competing standards, and again, you can have fragmentation of the industry. And it's good everybody's come together, on the 5G standard. I mean, there's an old manager of mine. He used to teach a course at one of the universities here in North America, and he used to go on about the need for standards and what could happen actually if you didn't participate in those standards. And his example was railroad tracks back, I think it's in the late 1800s in the US, whereas you had these competing standards there. And the industry has it kind of like evolved. It couldn't support those competing standards, so you get some consolidation. So you might start off with some of these problems, but eventually, some of them go away, and some of them don't go away. So standards bring a lot of good to the industry, but there's also a lot of things a lot of challenges that we have to deal with as well.
Thank you. Yes, it's been very useful to see that. I hope the audience understands also the challenges that to make a standard.
Yeah.
So, but now let's go maybe then to Wanshi. So I know it's a difficult challenge now, but if you can give a brief idea, what are the ingredients of 5G? So when we talk about 5G standards, what are the ingredients of 5G? I know it's a lot.
Yes. Yes, have to share this from my perspective. I think we know 5G in 3PP start with the first workshop in September 2015, so it's been quite a while. Even from the very start of 5G, we had very, very good planning per se. We look at IT requirements and we identify the so-called 3 pillars for the use cases. This eMBB, involved mobile broadband, ULRC, ultra reliability, low latency communications, and massive MTC, machine topic communications. So these kind of three pillars that set the foundation for what 5G should target to accommodate. And then based on that, we have a very forward-looking framework, a very flexible framework, so that we can commercialize and standardize 5G with all different kind of use cases in different spectrum. And we're not spectrum for any new generation standard is critical. So 5G is first time we were able to make sure that the millimeter wave band can be efficiently used and can be reliably also used. With a reasonable coverage is also very important. And also deployment wise, we have cover not just outdoor, indoor, also industry settings, all these different settings to make sure, we can accommodate use different services with different spectrum and different deployment scenarios. Of course, when it comes to detailed technology, there's a lot of technology embedded. I won't go into details, but what I like to say that the lesson we learned from 4G is very helpful for us to shape the first generation of the first release of 5G standard by consider all these different cases, and this really make this standardization the framework very future proof. This enable us to, after the first release of Release 15, in Release 16 we're able to provide a so-called vertical expansion, and basically to accommodate some new services, some new needs, particularly from vertical industries. And then this accommodation got further expanded in 17. Of course, Barbara also mentioned at the beginning, now we're in the so-called 5G Advanced. It's the first release of 5G, and we'll also use the same framework for us now to not only to explore some new projects which can suit us from the immediate commercial deployment perspective, but also to enable us to look at something aiming for a longer term commercial perspective. To give example, we're now doing study in 3PP, talking about this AI machine learning to see how this could fit into 5G framework. Anything we can learn, any including any shortcomings we may study to see. It could also be beneficial in future generations. Another one is duplexing evolution is also an important topic for us to learn more about the potentials 5G can offer, and also to, if any kind of lesson we can learn, it will also benefit future generations. So all in all, I think we derive 5G to be a really, how to say, a connection fabric, if you will, to not just consider traditional mobile broadband services, but rather to be really inclusive and to start from day one. And I think so far it proved to be very effective and very useful. Yeah, thank you.
Thank you. That's very good. So it's good also to hear that kind of assessment and try to build a framework which is the future proof and learning from the previous experience. And then if we look at the future, Sebastian, so what do you see as the extension of the capabilities where we go beyond 5G? So you can talk about advanced, but there's whatever you see in pipeline.
Thanks, Barbara. Yes, so building on the service paradigm, which was the original baseline 5G, starting with Release 15. So Release 18 is, just to put the timeline in perspective, is what we call 5G Advanced. So stepping back into the actual underlying capabilities, why do we need this advancement in going beyond the baseline? So starting out, the 5G vision had three major service categories. We had the enhanced mobile broadband, then massive IoT, and then the ultra-reliable low-latency communications. So most of the focus, because of the historical precedence of voice and video communications, it started out with enhanced mobile broadband. But now the major potential, or the service potential of 5G, as Adrian also alluded to earlier, is in the arena of massive IoT and ultra-reliable low-latency communications. Now that brings up the question of, okay, so how do we get there? And so we need to be able to extend this idea of virtualization into the radio layer, meaning that we need to be able to slice the resources, spectrum resources, how the resources are allocated with fine granularity. Ultimately, I guess we could go down to the actual resource blocks if needed, to be able to delineate and utilize the available resources, including the spectrum resources, in a manner that's efficient, while at the same time catering to the KPIs and the QoS demands of a given service. So now that entails a lot of cross-layer collaboration, which did not exist going back in history. But now it's becoming apparently clear that even at the application layer, there needs to be an awareness of what kind of access technologies are going to be used, what kind of frequency band. Is it below 6 gigahertz, or is it in the millimeter wave spectrum, depending on what the requirements of a given service are. So when we talk about services, there's virtually no boundary, right? It's anything that could improve the quality of life from a human perspective, whether it's through a human-to-human interface or whether it's through a human-to-machine interface. It's open game. So now we need the infrastructure, the capabilities from a standardized perspective, so that we can ensure consistent and interoperable behaviors, we need to be able to develop that ecosystem. Another aspect that's coming out of it is functional virtualization, which requires not just the placement of these functions within, let's say, a core network or a radio network, but to be able to place it as needed in a cloud or a local environment. So the environment could be networking, computing, and storage resources may be local, such as at the network edge, closer to the user, or it may be remote. And a good example would be like wearables, which may not have many onboard resources, but it could offload depending on what's needed to the edge resource capabilities. So end-to-end network slicing, to me, together with some level of situational awareness of what the user experience is and what the service is, it would actually enhance the capabilities of that or the experience of that service. So these are the directions that we see taking place in the service paradigm, what we call the cloud native capabilities in terms of microservices, containers, because these can be moved around. And another aspect that's going to come up, which is part of my next, response to the next question, is what does this entail? And I'll stop there. I'll just say that, okay, flexibility entails complexity. Thanks.
Absolutely. No. Then let's go maybe more looking at the actual deployments of these standards. So if I go back to you, Adrian, so what can we do actually to accelerate the adoptions to the market of these standards? Obviously, it takes some time, we know that, but what can we do?
Yeah. As I said before, I mean, I gave IMS, which was an example of something that took an awful long time to probably come to market. But maybe sometimes it's better to step back, and if you're looking kind of for like some functionality, it is the way that I mean, as I said, some of this stuff may go across multiple releases. It might. I mean, is there a way, at the beginning of the standards process, to actually, select functionality that, that is the bare minimum that you need, and then maybe you can put something proprietary on top of it, and then wait for, for the next release to come along. Or there's another one that that I've worked on, which is where you can develop part of the standard, and you can let another standard organization that develop it. I mean, one of those that I've been heavily involved is CV2X, and in CV2X is about cars, communicating with each other. I mean, you have functionality again. I mean, I think this was developed back in the late 90s or early 2000s. That was based on an IEEE technology, and then you had all of the application layer standards developed by SAE, which is another organization. And they became very mature and everything, and then there was an opportunity for the cellular industry to get involved with the CV2X. So I think that's where kind of what the C comes to in the V2X, because it's cellular now. And so you had the cellular industry just concentrate on creating the connectivity standards. You did. The lower layers, and then you left the existing functionality that already been developed by the SAEs of the world, and then brought those together. So you can develop the functionality within one standards forum, and then leverage the other standards on top, and then produce a product that you can roll out at the end of the day. And the other thing is also kind of like taking that some of that functionality and actually prototyping it. Putting it in test beds, which is like Open Generation is doing, and then actually, prototype that there and go and test it in a controlled environment, and then demonstrate, to the industry, that it works, or in some instances it doesn't work, and then bring back those tests and put them into the standards forum. because the standards forum is kind of like, a lot of times working in a vacuum. I'm going to say it's very much a paper exercise. A lot of us also do some, research and a lot of background, but it's good to sometimes take some of those practical, real life experiences, and then bring them back, because, there's always something that pops up, in the real world that you never thought of. So there's an opportunity, to do some of that kind of like prototyping, and then bring it back. And then I suppose the last thing, going on with the story of, with IMS was, you ended up with this, mammoth set of standards, on which parts do you pick and which parts, do you don't pick? So there's an opportunity there, for the industry, to get together and decide as an industry what, these are the kind of like bare minimum things that we need, to kickstart this industry off. And I think that's one of the things that actually, helped, IMS get deployed in the cellular industry. There was an activity called One Voice, which turned into a GSMA document called IR92. It did, where there was a small number of key players that joined, and basically the participants then increased, and that document is now continuously being evolved. And I think, and I've forgotten the name of it now, but there's a version of that for 5G as well. So there's a lot of different types of things that that we can do out there, to help accelerate those standards. Because sometimes those standards will sit there and they'll never be used, and sometimes they won't be used because the industry as a whole doesn't know how to to pick them up, and go with them. They're so vast. Which parts do you want? So I think those are some of the things that we can assist and help.
Definitely, that's good, and maybe it just brings me to the next questions, which is also then leads maybe to one of the audience questions. So, what is the challenge when we do stands and also we have the verticals? So as we mentioned before, 3GPP traditionally has always been telco. Now we expand, to different verticals. So what is the challenge just now to do the stands and for these verticals?
Yeah, thank
you. Sorry, yes, over to you. So you are the stand-up.
No problem. Yeah, thank you, Barbara. And this is a very good question. I would say that Adrian also talked about some problems with stand-up before. I would rather call it the challenges instead of problems. But we're facing a lot of challenges these days. If you go back to LTE days, especially the beginning of LTE, is primarily this traditional mobile broadband, these kind of requirements and services, and the number of delegates, for example, in the largest working group called Round 1, the physical layer, at the time it's about 200 people more or less. But now, especially since the start of 5G, we're seeing 500 people, sometimes even 600 people. If now we come to round plenary, it's similar situation. In round plenary now, is already close. Today we just finished a session. Today the conference call, I didn't count, but I think easily over 400 people attending conference calls. So it's I would say this is a happy problem or good problem. At least the changes that happy to see. But of course, very important part to manage. Now talking about vertical in particular, I would say probably I can categorize into three things. One is that, relatively speaking, vertical is more like a newcomers to 3GPP. There's always a learning process. I think important for the newcomers to understand the procedures, how things are handled. For example, contribution-driven, consensus-based, all the kind of different things. Indeed, actually, in June, in a plenary meeting in June this year, we actually held a new conversation to try to provide all the three TSG chairs, try to provide some information for newcomers to learn how 3GPP works. And this is all important. It's also important for newcomers not to be shy. When they have any questions or any issues, or even just some random chatting, it's very important to get familiar with the process, get familiar with the people, because this is going to help a lot. I can tell you that the reason e-meeting is not that efficient is because physical meetings is all easier to talk to people face to face. If you know some people well, things will become much easier than somebody completely stranger. So that's one thing. I think it's important to know that. Another thing, of course, we are working kind of different things. Eventually, they're going to location covering everything. So it means that we have to have a good integration, if you will, of all these different use case requirements into a single spec. In many cases, not easy. So it means that, for example, for NTN or V2X, it's not just that for you to understand your specific requirements. It's also important for you to understand what's already there, what the requirement from some other players, so that all these things can be consolidated somehow into the same framework or the same set of projects, so that all the resulting locations can be integrated into a single set. This is actually very important, because it even doesn't make sense to have something completely independent from the existing spec. That just from marketing perspective, from standardization perspective, from a commercialization perspective, it doesn't make sense. So this integration part is also very important. Another thing I think Adrian touched upon also on this is our release schedule. Our release schedule in 3PP is still based on this traditional smartphone cycle, if you will. So largely 18 months per release. And in release, we approve a set of projects and work on the details. But of course, in many cases, this may not be ideal for the vertical business, because vertical typically may have a longer cycle. For example, V2X or MTC. This once they have released, is maybe commercial deploy for a long time, and you may not have this kind of annual refresh of the equipment kind of things. So that's something is not perfectly aligned with the product cycle of the vertical requirements. But there's also something important for us to realize, that there's always a competition of the resources. We have a lot of requirements coming to 3PP, which is definitely a challenge. As I said, I see the happy challenge, but it is important to understand from each side, including the vertical side, to really have this kind of phased approach how things should evolve, and to really know that that's of course involved a lot of even per company discussion and cross company coordination things, to really know what is really urgent from commercial deployment perspective. Because in many cases, and many companies, which I don't blame them at all, it's just a natural thing. Everybody wants to do more. I like this, you like this. Eventually we have to do as a group to see what's the best for the especially from a commercial perspective. This is always the challenge part. Yeah, thank you.
Thank you for that. So we have a couple more questions, but just maybe I want to point out that yes, I can say that this could be a bit scary or challenging the first time you go to a standard if you're not used to that type of processes, particularly into GPP, with the amount of people that you have. And the question that we have for the audience, I just want to pick it up. They ask which industry vertical would benefit most of the 5G. Personally, I would say the one that put most of the effort to do anything in the 5G in the standards. If you expect us, which are a technical technicians, to work out issues from completely different vertical, it will not go right, I guess. But maybe just quickly to you, Wanshi Chen, so what do you think would be the vertical that benefits from 5G?
No, I think I wouldn't single out any particular vertical industry in terms of benefit. I can tell you that now, if in 3PP, if you look at the participation from vertical industries and the specification that we already specified so far, is a very wide range. We pretty much we're talking about V2X. I think I also mentioned earlier. This MTC thing, we pretty much reuse this so-called Neighbor IoT eMTC design from 4G days, but do necessary change to be up to support by 5G framework. We have NTN. We have this unlicensed spectrum. We also now, arguably what they call not XR is another thing that we've been trying to see how to better support these different use cases. Just name a few. That's a lot. It's I think from at least the way I see it, we are trying to accommodate the needs from all industries and to try to as I said, there's a happy problem. Try to use the limited resources that we have and try to serve the best needs across different industries. So I wouldn't say just benefit a particular industry, but rather is kind of a very, very wide range.
Understood. So yeah, we're getting close to our time, but maybe I want to pick one thing. Is we can go a little bit brief. There are 2 points that I really want to cover. One point is Adrian, if you can be brief, is one standard is enough? What are the other organizations like you in OpenGen? What they bring? You mentioned briefly before what you can bring, but can you say maybe we need what we need to do?
I think that, they bring another forum, for people who are not involved, kind of like in the direct standards process, to actually influence, the standards. I mean, take OpenGen. I mean, there, we're deploying private networks and doing experiments on those networks. But we need participation from the actual users of the drone ecosystem. Those people that are actually going to be flying the drones. What are their operational challenges and problems that they're experiencing, and it gives them a forum to voice what they need, and specifically for us, we can go away and do some experiments in that area, and then we can bring those experiments and results back into the likes of 3GPP. Where otherwise, 3GPP might have no visibility of that, and they might develop standards that, that they feel, are benefiting the industry, but, the actual users, actually don't need that, or they find that lacking. And there's many kind of like, where fora that, do that. You're going to look at 5GAA as well. A lot of automotive, players in there. If you go and have a look at 3GPP, you'll only find a collection of them that want to actively participate. But there's a lot of other people. You got the main manufacturers, and you got the tier 1 and tier 2 suppliers as well. Who basically take up this technology and then use it. So and GSMA is basically probably the one that a lot of us are familiar with, and so that's you'll find a lot of operators that participated in there that never participated in 3GPP. And GSMA also looks at, the operational aspects of deploying those networks. We have the standards, but, the standards don't build the networks and deploy them in the physical, real environment, and don't understand that, some of the challenges there. So it gives them another forum, to make sure that they can get their networks, basically up and running, and a way for them to feedback maybe particular things that they want. It does.
Perfect. I think we are at a time, but I just want to get one quick last word for you, Sebastian. I know it's there will be more information, but what autonomous frameworks bring? Just we have a few minutes, but just push for the next.
Sure. Sure. Thanks, Barbara. So just to follow up on what Adrian and Wanshi have been saying about the challenges, the contextual challenges specifically. So I'll put that in perspective in terms of why do we need automation. So the context for that is system complexity resulting from virtualization and the diversity of demands associated with emerging verticals. And as Wanshi mentioned, the 5G actually supports all kinds of verticals, but the challenge is twofold. One is the architecture itself is changing in terms of disaggregation and highly decentralized system, which means that when we try to virtualize it and satisfy a given vertical, whatever it needs, then the complexity goes up in terms of how do we actually orchestrate an end-to-end network slice to support that particular vertical or service. So then the next question comes, okay, so then how do we manage that complexity? We need intelligence in the system and using AI and machine learning models. And the next question is, okay, so how about just automating? Don't we have programmatic automation? But the challenge with that is that the rule-based simple automation, as I like to call it, does not have any awareness of dynamic changes in any given environment. So we need feedback loops. Feedback loops combined with cognition is what constitutes an autonomous system. which leads to what I call self-chop behavior, self-configuring, self-healing, self-optimizing, self-protecting. Which means that there are two reasons. One is the human response limits are very limited in terms of managing, let's say, very fast reaction times. So we need intelligence for that. To manage distributed complexity, we need intelligence for that. So the autonomous system actually satisfies all of them. Of course, given that it needs to satisfy those requirements for automation, the question is the autonomous system itself changes the landscape in terms of how the system is operated, minimalized human intervention, which requires less operational cost because we are minimizing that, but then we need to be able to keep building on the models that adapt to new environments, but albeit at a much lower pace without requiring manual intervention because it's not feasible to do it that way. So that's why we need an autonomous system that's self-sustaining and scalable at the same time. Thanks.
Thank you. I think we just running a little bit out of time. So I just want to thank you everyone for joining this panel. There's a lot of questions, but we will try to see maybe to answer it after the session. So thank you again for all the speakers. It's been a pleasure. And I pass it over to back to the moderator. Thank you.